The hexagonal architecture, also known as ports and adapters architecture, was first described by Alistair Coburn in his paper Hexagonal Architecture, published in his website in the year 2005. The article begins with a simple explanation about the idea behind this architecture, where he wrote: create your application to work without either a UI or a database. So you can run automated regression tests against the application, work when the database becomes unavailable, and link applications together without any user involvement. So, in the simplest form, this is how it looks: the application or the domain logic at the center, and the adapters and ports are all around it. And the intent behind this architecture, according to Alistair Coburn, is to allow an application to equally be driven by users, programs, automated test, or batch script, and to be developed and isolated and tested in isolation from its eventual runtime devices and databases. And how we can achieve that? We can achieve that separation and isolation with the help of ports and adapters. As he writes, when any driver wants to use the application at a port, it sends a request that is converted by an adapter for the specific technology of the driver into an usable procedure call or a message, which passes that to the application port. The application is blissfully ignorant of the driver's technology. When the application has something to send out, it sends it out through a port to an adapter, which creates the appropriate signals needed by the receiving technology. That can be human or can be some automated script. So basically, the entire communication between application and the outside world is happening through ports and adapters. And the application has a semantically sound interaction with the adapters on all sides of it without actually knowing the nature of the things on the other side of the adapters. According to Wikipedia, the hexagonal architecture is an attempt to avoid known structural pitfalls in the object oriented software design, such as undesired dependencies between layers and contamination of user interface code with the business logic. If you can see in this architecture, the domain logic is completely independent of the external interfaces, like the UI or the database or web services. The external interfaces are implemented as adapters or ports that translate the data from the domain model into a format that can be used by the outside world and vice versa. This allows the system to be easily tested, maintained, and modified as changes to one layer do not affect the other layers. So, in a way, the hexagonal architecture also promotes the use of dependency inversion, where high level modules depend on the abstractions rather than on concrete implementations. This allows for greater flexibility and easier testing, as the dependencies can be easily swept out for mock objects or other implementations. And that makes us to think that what are the benefits of such an architecture? So it provides several benefits. Some of these are these, uh, like flexibility and maintainability is the very first benefit. It promotes loose coupling between the layers of the system, which makes it easier to modify, add new features, or replace components without affecting the rest of the system. And that makes it easier to maintain, as changes to one layer can be made independently of the others. So, flexibility and maintainability is the first benefit. Second, with that comes the testability. The more flexible and maintainable your system is, the more testable it is. And hexagonal architecture makes it easy to test the system, as the domain logic is completely isolated from the external interfaces. So you can easily write the automated test for the system, which helps to ensure that the system is working as expected. Then the third benefit is reusability. The hexagonal architecture promotes the use of dependency inversion, where high level modules depend on abstractions rather than on concrete implementations. This makes it easier to reuse components in different parts of the system or in other systems. Next, we have the benefit of separation of concerns. Hexagonal architecture helps to separate the concerns of the system, which makes it easier to understand and reason about the system. This also makes it easier to identify and fix issues in the system. And next, we have the scalability. Hexagonal architecture can be scaled horizontally by adding more instances of the same components or vertically by adding new layers or components to the system. This makes it easier to handle increasing loads or new requirements over time. And these benefits are also some of the key takeaways from the blog post of Alistair, which is available in his website. So, hexagonal architecture can be applied to a wide range of systems, including web applications, desktop application, and mobile application, and can help to promote good software engineering practices and ensure that the system is robust and reliable. But there are certain limitations as well, and there are certain drawbacks related to this. The one that is most commonly talked about is the increased complexity. Hexagonal architecture can add additional layers of abstractions and indirection, which can increase the complexity of the code base. It can make it harder to understand the code base and can be more time consuming to implement. Some people highlight the over engineering aspect. They say that hexagonal architecture can lead to over engineering if it's not implemented carefully, as developers might be tempted to create too many layers or try to abstract or away everything, which can make the code base more complex and harder to maintain. Performance overhead is another highlighted limitation of the architecture. Additional layers and indirection required by hexagonal architecture can add some performance overhead, especially when compared to simpler architectural styles. Testing is again a little bit complex in this particular architecture as it requires more mocking or simulating the input output ports to test the core logic. This can add additional complexity to the testing process and require more effort from the testing team. And the learning curve can be higher for some developers, particularly for those who are not familiar with this pattern. It can take some time for the developers to understand the principles behind hexagonal architecture and how to apply them correctly. So, in summary, we can say that hexagonal architecture can provide many benefits, but it's not a one size fits all solution. It's a powerful pattern for creating flexible, maintainable, and testable software systems, but it's not a silver bullet for all applications or in all scenarios. And that's the case with all kind of architectural patterns out there. But what is common in all of these popular and widely used architectural patterns is that they all have the same objective, which is the separation of concerns. That is something we need to keep in mind.